Initiation of motion is the threshold at which bed material sediment particles start to move in open channel flow. This threshold is important in channel design in order to assure sediment movement and avoid clogging. The Froude number F equal 0.08 has often been taken as a minimum value to prevent clogging. In here, we derive a general Froude criterion for initiation of motion, confirming the validity of F equals 0.08 for a wide range of practical applications. The Shields criterion for initiation of motion relates the dimensionless shear stress tau star with the boundary Reynolds number R star as shown in this figure. The solid curve separates motion above the curve from no motion below the curve. The Shields criterion is in which tau sub naught is the bottom shear stress, gamma sub s is the specific weight of sediment particles, gamma is the specific weight of water, d sub s is the sediment particle diameter, and tau star sub c is the dimensionless critical shear stress. For practical applications, the dimensionless critical shear stress tau star sub c can be taken as a constant for a wide range of boundary Reynolds numbers R star. The quadratic friction formula of fluid mechanics is in which rho is the mass density of water, F is a friction factor for open channel flow equal to 1/8 of the Darcy-Weisbach friction factor, F sub d, and V is the mean velocity. The Froude number is in which g is the gravitational acceleration and d is the flow depth. Replacing this equation and this equation into this equation results in in most cases, the ratio gamma sub s over gamma is equal to 2.65. Therefore, the Froude criterion reduces to as a convenient approximation, the Shields curve suggests a value of critical dimensionless shear stress tau star sub c equal to 0.04 for a wide range of boundary Reynolds numbers. Therefore, the friction factor F varies normally in the range 0.002 to 0.005, which corresponds with Darcy-Weisbach friction factors between 0.016 and 0.04. Here we assume a mid-range value of F equal to 0.0035, corresponding to F sub d equal to 0.028. The Froude criterion reduces to for a given particle diameter relative to the flow depth, this equation states the Froude number that must be exceeded to assure initiation of motion. For instance, for d sub s over d equal to 0.0004, that is, a particle size of 0.4 millimeters in 1 meter of depth, this equation reduces to for d sub s over d equal to 0.0003, this equation reduces to as an example, assume A, friction factor F equal to 0.005, a high value, and B, a relative particle diameter d sub s over d equal to 0.0005, a high value. The application of this equation results in terms of Manning friction, for a hydraulically wide channel in SI units, the Froude criterion for initiation of motion is For example, for flow depth d equal to 1 meter, mean diameter d sub s equal to 0.4 millimeters, and Manning's n equal to 0.02, the Froude criterion is The Shields criterion of river mechanics is expressed in terms of the Froude number, enabling the calculation of the minimum Froude number for initiation of bed material sediment motion in open channel flow. Given critical dimensionless shear stress, friction factor, and relative particle diameter, the developed relation confirms the validity of Froude number F equals 0.08 is a convenient descriptor of initiation of motion in most cases of practical interest.